No, yo creo Cristian, sí.
Bueno, entonces nuestro invitado Hlynur Oskarssón, ¿verdad? Es de la Escuela de Agronomía de Islandia. Nos conocimos hace 15 años, no sé, muchos años, en el marco de un programa de ECOS europeo, que es un programa que permite agrupar a la gente que tiene sobre un tema juntos para hacer una red. En este caso era sobre los andosoles de Europa, así que había, no me acuerdo cuántos países, pero no sé, como 20, 30, y de diferentes instituciones. Había este dinero era bastante, lo que nos permitía hacer viajes de un país a otro, como 50 personas cada vez, tomar muestras, hacer análisis y sacar, bueno, participar a publicar cosas y hacer síntesis. Muy interesante. Este programa desgraciadamente no existe en América Latina y sería súper bueno que pudiera existir. Y esta red es un poquito lo que quisiéramos hacer, nada más que no tenemos dinero para invitar a, a todo el mundo a viajar y nos enfocamos en una primera instancia solamente a Chile y Ecuador, hacer este tipo de cosas, pero ojalá que pudiéramos hacerlo con todos los países latinos que tengan andosoles, una meta y un sueño, a ver si los sueños se concretizan de vez en cuando. Bueno, entonces Hlynur es profesor en la Escuela de Agronomía de Islandia y nos va a presentar los suelos del país, de su país, que bueno, es difícil no encontrar suelos que no sean volcánicos en Islandia, ¿verdad? Y por eso que es parte también de esta red, porque ellos tienen una experiencia que no necesariamente todos tenemos aquí. Y otra forma de, también experiencia de agrícola bien interesante. Y creo que podemos, bueno, tenemos ya relaciones y hay intercambios que pueden ser muy fructíferos. Hlynur, it's your turn now. Bueno, entonces como le decía, está en inglés. Si alguien no entiende algo, lo escribe en el chat y paramos y hacemos la aclaración y al final, como siempre, vamos a tener como una hora de discusión entre todos. Las preguntas se harán en español si quieren o en inglés directamente. Depende de ustedes. Hlynur, it's your turn now.
Okay, thank you very much. Let's see, do the screen sharing. Okay. Okay, and I assume you can all see this, right? Okay, very good. So yes, my name is Hlynur Oskarssón. I'm at the Agricultural University of Iceland, and I will be talking today about giving a general talk about the soil environment, the volcanic soil environment and soils of Iceland. But before I start, I want you to all to know that I am not a soil scientist. I am an ecologist or a landscape ecologist who works with soils. I work a lot with soils and hydrology and vegetation and so on, but I'm not the soil scientist. And a lot of the things I will be talking about today are based on the work of, okay, now I cannot flip. Okay, let me see why. Okay. Is based on the work of Dr. Ólafur Arnalds, prominent soil scientist here at the Agricultural University of Iceland. And if you want to read more or know more in detail about the things I will be talking about today, I recommend the Soils of Iceland by Ólafur Arnalds in the Springer World Books series on soils. So, anyway, the outline of my talk, here it is. I will be giving you some background information about Iceland to begin with, and then I will speak about the soil environment, and then the soils of Iceland, and I will end up talking about soil degradation and soil restoration. So first about the background information. Iceland is situated in the North Atlantic between Greenland and Northern Europe, Norway and Scotland and Ireland. And it's mostly located between latitudes 64 and 66. The Arctic Circle sort of skirts the northern shore. So it's a northern area, subarctic area. Just a few key facts. It's just a little over 100,000 square kilometers in size. There are 340,000 inhabitants. It's not a very populated place. Like I said before, the environment is subarctic. The island was settled by humans approximately 1100 years ago, around the year 900. So human habitation is rather recent. And the mainstay of our economy is fisheries and tourism. But in terms of the soil environment, it's the land use, main land use is agriculture. On the other hand, being such a small population, and the agriculture is not that extensive. It's only 1.2% of the land area is under cultivation, and it's confined mostly to the peripheral lowlands along the seashore. The number of farms is around 3,000, and hay fields, most of the fields are hay fields to gather fodder or hay for the livestock in wintertime. But we have also some barley fields. But the whole country, on the other hand, is grazed by livestock. And these are breeds that the settlers, the Viking settlers brought with them from Scandinavia, and they've never been bred with other breeds. And these are mostly sheep, but also cattle and horses. Just a little bit on the geology. Iceland is located along the Atlantic Rift Zone, where the two main northern hemisphere tectonic plates meet, the Eurasian plate and the North American plate. And most rift zones where tectonic plates are drifting apart are at the bottom of the ocean. But Iceland should therefore maybe not exist, so to speak. But because Iceland is a hotspot, there's a mantle plume underneath the Iceland. Iceland is actually above the sea surface. There are currently 30 active volcanic systems. You see them here in red and yellow. And on average, there is an eruption every 5 years. So it's very active in terms of volcanically. Most rock formations are basaltic in nature. The types of volcanoes they're highly variable. It's very common for long basaltic fissures to open up. The ground will just rip up and open. This can be on totally level ground, like the famous Laki fissure from the 1700s, which put out enormous quantities of material, lava and tephra. But there are also central volcanoes, sometimes forming calderas, with repeated eruptions in the same locations, producing lavas and tephras and lahars, etc., etc. And like here, you see the Eyjafjallajökull eruption in 2010. And like the Eyjafjallajökull eruption, some of these central volcanoes are located underneath glaciers. And when we have an eruption inside the glacier, under the glacier, it almost invariably produces a lot of volcanic ash or tephra. And it causes catastrophic floods. So highly variable forms of volcanism. The climate, like I said before, it's subarctic. You think cold place. Yes, precipitation ranges between 300 and 2000. But if you look at the annual temperature, yes, it doesn't get very warm in summer. And the annual temperature is mean average annual temperature is 4 degrees. But note that it's only around 0 in the coldest month in January, which is unusually warm for that place this far north. And the reason for this, of course, is that the North Atlantic Current, the part of the Gulf Stream, brings warm waters that circulate Iceland and make the climate, therefore, more temperate than would be expected for latitudes just south of the Arctic Circle. Why is this important? Well, the warmer winters than normal in these northern latitudes, which means very frequent freeze-thaw cycles, which affect the soil environment immensely. I'll get back to that. It's also a very windy place. Just south of Iceland, between southern Greenland and Iceland, is the formation. It's a place where often the Icelandic low, a very strong center of a low atmospheric pressure, forms. And it, along with the Aleutian low, is the strongest low pressure system in the northern hemisphere, often reaching hurricane force winds, although not a hurricane in itself. And so very windy place, which also has affected the soil environment tremendously. I will get back to that. Okay, so that was just a little bit of background information on Iceland and the general features of the environment. Now I will talk about the soil environment, that is the factors and processes affecting soils and soil formation within Iceland. Well, yes, Iceland is produced through volcanism, but it is also tremendously shaped by glaciation. It was entirely glaciated during last ice age, and many of the soils have hence formed on glacial till. And glaciers currently cover approximately 10% of the surface. It's a very active glacial environment with glacial rivers depositing tremendous amounts of silt, sand, and gravel onto low-lying areas. So we have many source areas of fine, loose materials, which is important in terms of the soil. The glaciers produce fine silt deposited on over ever-changing floodplains, and volcanic eruptions cause massive flooding, leaving loose sediments on the floodplains. And the interaction between the ocean and glacier river creates very vast and stable aeolian shore areas continuously charged with fine materials. So we have all these source areas, vast areas with lots of loose material. And remember, it's a very windy place. That means this material can easily blow around and be redistributed through aeolian processes. And here we see one of these areas during a storm. You see all the dust picking up, and then this gets distributed over long distances. We've seen plumes of this extending 600 kilometers out into the ocean, and all environments in Iceland receive hence aeolian dust, deposition. And here we see a map of the deposition rates in Iceland. It's lowest in the far western part, but the closer you get to the rift zone, the volcanic active areas and the glaciers, you have tremendous rates of deposition. Iceland is the main source of dust in the northern Atlantic. And this aeolian deposition means that soil thickening rates are quite high, up to millimeter a year. But there's also very rapid chemical weathering rates reported from Iceland. So most soil have formed in place since the last glaciation. Most of them started to form about 8,000 to 9,000 years ago. And because of this constant deposition, they are being constantly recharged and by material deposited on top of them. So that was the aeolian deposition and importance of that. But I mentioned the freeze-thaw cycles, the frequent freeze-thaw cycles during the winter months. We can easily have 15 freeze-thaw cycles during one winter. And hence cryoturbation is a major influence in Icelandic soils and ecosystems. We have lots of needle ice forming all the time and tearing up loose ground, lifting bits of soil and tearing up vegetation. So if the vegetation has been degraded or if there's erosion going on, needle ice will come in and exacerbate the situation, make it worse. Here you see how this is a small erosion spot and needle ice starts to work and tear up, and it's very difficult for vegetation to settle in such areas. But the frost effect also makes the thúfur, very common feature, or hummocks, very common feature of the Icelandic surfaces. Here you see inside one. And they can be very, very large. If there's the water table is shallow, then it's a classic example of pumping of water from the water table to the freezing front, forming these large thúfur or hummocks. But the freezing effects, if vegetation is lacking in some, like in many of our desert areas, well, oh, I should mention this first. This is intensified by grazing. If you have heavy animals grazing, then the formation of thúfurs is intensified tremendously. But in non-vegetated areas, frost will also have its effect. Frost causes sorting of the material because of during winter time, ice forming in areas with shallow water, and it causes the sorting of it with finer materials in the center and with gravel and rocks rolling down and so forming this pattern ground. This is very common. There are other things like soil fluxion and creep, wave movements down slopes caused by freeze-thaw cycles are very common in many areas of Iceland. And so just to summarize these main processes and factors affecting the soil environment. So we have active volcanism and glacial processes that shape the surface and produce tremendous amounts of fine material, which is ripe for aeolian redistribution. There is considerable aeolian deposition onto large part of the country. And frequent frost-thaw cycles cause cryoturbation, which shapes soil surfaces and sorts soil material. Okay, then on to talking about the soils of Iceland. I'll give you a brief overview of the main soil types. So these are the 5 main types. There are more types, but these are the 5 that are approximately over 95% of the soils of Iceland fall under. The histosols, the Histic Antisones, Gleic Antisones, brown Anthols, and vitrisols. And I'll talk about these now in sequence. Well, histosols are, I know this talk of mine, I said I would be talking about volcanic soils, and well, histosols are not volcanic soils, but they are influenced by have antic influences in them. But anyway, we have histosols, not a great extent, 2 or 3%. The carbon is more than 20%. There's soils of the peatlands, or turberas, and they are commonly 3 to 6 meters deep. So we have them as much as 12 meters deep. Organic matter is mostly peat, and they're found in locations away from active volcanic zone. Because if they would be closer, they would receive much more minerals into them, and then the carbon would not be more than 20%. They are organic, but with antic influence. Then we have the Histic Antisones, which are also formed within the wetlands. Their carbon percentage is defined as 12 to 20%. And they're found in the wetlands close to the active volcanic zone, and hence always receiving material from both the volcanoes and also all of these dust source areas, be it from the glaciers or volcanoes. They are 1 to 7 meters in depth. They are rich in minerals and heavily influenced by aeolian deposition of tephra and eroded materials. Then the Gleic Antisones, keep talking about the wetland soils. The carbon is less than 12%, mostly found in intermittently flooded wetlands that are sometimes flooded and sometimes dry. They are between half a meter and 2 meters in depth. They're rich in minerals. They have a fluctuating water table, and there's presence of mottling. Then the most common soil type in Iceland, the brown Anthols. They are well-drained soils, and they're the common soils of upland vegetated areas. There's large variation in terms of, well, depth and clay content and texture and organic content and so on. They're most often 1 and 1.5 meter thick, and often the clay content is 20 to 40%, mostly allophine and very hydrate. And then we have these soils which we term vitrisols. They're the soils of the deserts or denuded areas, both natural deserts, but also areas that have lost the brown soils, brown Anthols have suffered soil erosion. And they cover 40% of the total surface area of Iceland. They are highly variable, but because they cover such a great extent, we believe, or we maintain, that they warrant a separate soil type because of their extensive distribution within the country. They are mostly some form of anthosols, or antisoils, but there are many different types depending on how sandy they are, or gravelly, or even clay content. They lack organic matter and nutrients. Very unstable surfaces, and hence both cryoturbation and strong winds can affect these areas tremendously. So the vitrosols are the soils of the desert landscapes like you see here, which are very common in Iceland. And here is a soil map of Iceland. And you see all the gray and yellow areas, mostly in central highland plateau of Iceland, but also up here and so on. These are the vitrosols. Then the other common soils are the brown Anthols and the Histic Antisones. And then the histosols are mostly found here in Western Iceland. So just a summary of the characteristics of the soils of Iceland. The most common parent material is poorly crystallized basaltic ash. There are very high weathering rates of the parent material, forming allophane or ferrohydrates or metal humic complexes in the wetlands. Extensive coverage of barren or desert surfaces, both natural and as a result of erosion. Extreme aeolian activity on many of the sandy deserts. And that leads to substantial deposition onto moist surfaces within the country. And the aqueous and anthols and the antihistosols, the organic soils, are a rare combination on Earth with properties of both, that is histic and antic. And then the very frequent occurrences of freeze-thaw cycles with immense impact on the soil environment. In terms of, this is a soil map of Europe, and we see that being that Iceland is mostly anthols, brown histic or the vitrosols, which are mostly anthols, it's quite unique within the European environment. And also if you look, it's the largest volcanic soil area in Europe. And also if you look at the very northern hemisphere, if you look at down at the northern pole and look at the circumpolar region, we see that Iceland, it's really Iceland and the Aleutian Islands and Kamchatka that stand out as the areas that are most prevalent with antisols. So it is quite apart in the northern hemisphere. So the last part of my talk, I'll talk a little bit about the soil degradation that has taken place and some of the efforts in trying to restore the soil environment or restore soils or initiate soil formation. Erosion, drainage, and restoration efforts. So large areas of Iceland were previously woodlands or shrublands or heathlands with more than 1 meter thick ridge anthols. You see the remnants here. You see the soil and the vegetation remnants. And this is an eroded area. And they are now barren vitrosols, and the desertification took place in recent centuries. You see here how thick the soils were. Here you see a human, and you see the brown anthosol, and you see the forces at work. This is a very strong, this is all wind erosion, and you see how strong the wind can be. It will gnaw at it. Once the soil opens up, the wind will gnaw at it and dry it quickly and blow it away. One might ask, how did this happen? Well, it's a combination of many factors. The soils are vulnerable. These are volcanic soils which lack cohesion. They don't have the regular plated clays. The vegetation is quite vulnerable. Remember, it's a subarctic environment, and it was not used to heavy glaciers. It wasn't until the humans came in with heavy glaciers. There were no land mammals in Iceland prior to humans arriving. And it's a very harsh climate, particularly windy, and with a very active cryoturbation because of the frequent freeze-thaw cycles. And then the arrival of humans and large grazing animals, which up in the highlands deteriorated the vegetation and particularly the root layer. And soon as the soil started to open up, wind could work on it and erosion started. And in large areas, you see the size of this here, sheep on top of this, what we call rofabarð, or erosion escarpment. And enormous areas. We have natural deserts, yes, as a result of the volcanism and the activity of the glaciers. But there's large deserts as a result of the soil erosion. I'll show you some images here now. You see all the escarpments, the former grasslands. This is a telephone pole, 4 to 5 meters high. So you see how thick the soils were. And this is how the soil works. And then these gradually get smaller and smaller with each year. The rate has been estimated in several places in Iceland. Just some imagery from these areas. And in many areas, particularly in the highlands, the only areas or only ecosystems that survived the erosion were the wetlands because they were wet, soaking wet. And so the soils were intact there. But we humans, we decided to drain these for agricultural purposes in the beginning, but then more for sort of to create rangeland. Only as minor percentage of these were turned into agricultural fields. So we drained wetlands extensively during the second half of last century. This is an image from southern Iceland. This is the town of Selfoss, if you're familiar with Iceland, only 40 minutes away from Reykjavik. And you see the yellow lines here are the ditches, the ditch networks, the drainage ditches of wetlands or peatlands. We have mapped all of these. This is another image from Western Iceland. Here's the town of Akranes. And you see that all the lowlands really are just, basically the peatlands have all been drained. You see ditches everywhere. And if you look at Iceland, the ditch network now all fusing together and forming yellow color, you see it really defines the lowlands of Iceland around this is where humans live. It defines the areas of habitation. It's a very extensive network with 34,000 kilometers of ditches. It's almost enough to circumnavigate the Earth. So it's extensive. This was carried out, this was looked at as land reform, and it was subsidized by the government. Like I said in the beginning, for the first 15, 20 years, the farmers were draining to create hayfields. But then once they had enough hayfields, we continued draining. It was looked at as land betterment, and we just kept on draining. There was never a cost benefit analysis, and now we have altered most of the peatlands. This is problematic for many reasons. For example, it changed the hydrology of many rivers. We're losing nutrients. It's leading to erosion in some of this network and so on. But one of the main problems is that once we pull the water out of the peat or the organic matter and oxygen enters, it starts to break down, and it's an enormous source of carbon to the atmosphere. It's the #1 source within Iceland. So, and yes, we are using some of these areas, but only 15% of these areas are fields. 85% of the drained areas we are not using, except for some of it you're using for grazing. So the question is, what can we do in terms of all this soil erosion and these eroded surfaces, and what can we do in terms of the drained areas if you're not using them? Well, farmers, both the farmers and the governmental soil conservation service have been battling the soil erosion for over a century using all kinds of means. Here, a farmer they've devised this apparatus that shreds a hay bale and spreads it over the soil erosion escarpments. Here you see people spreading old hay over erosion areas, and this will then stabilize and vegetation will settle in. And then in the denuded areas, we are putting up fertilizer and seeds and so on and re-vegetating them. This is large scale, and actually thousands of square kilometers have been re-vegetated, and soil formation and development and organic matter has started accumulating within the soil. We have also started, our farmers have started filling in ditches in areas where they are not using, where there are drained peatlands, and this seems to work quite well. This is some images from such areas, and this is a restored peatland by this farmer here, and it functions well, and we're maintaining the carbon in the soil. We're not losing it into the atmosphere. So it seems to work quite well. Anyway, so basically, that's all I wanted to say. Thank you very much.
Thanks a lot, Hlynur. ¿Todo el mundo entendió?
Many thanks.
Sí, ojalá que sí.
Yes.
Bueno, so thank you for your excellent presentation. I guess that everybody understands all, and I have some questions. Bueno, tengo unas preguntas. Bueno, primero mencioné el tema de la red sobre Anthols de Europa y no mencioné el coordinador, que es François Bartoli, o que era François Bartoli. Él se murió hace unos años, demasiado temprano, y era un científico y un hombre muy, muy genial y simpático, y es realmente una pérdida. Así que no quiero olvidarlo. Bueno, tengo unas preguntas, Hlynur. Voy a hacerlo primero en español y luego en inglés. Primero, la temperatura que mencionó era, me parece, solamente sobre las áreas de Islandia y no sobre todo el interior. Lo otro es a quién pertenece la tierra en Islandia, la que no está cultivada, si hay algún dueño, porque ellos tienen un sistema bien particular de gobierno y que viene de los ancestros noruegos, vikingos. Y lo otro, al nivel de cambio climático, se hace notar en Islandia como en toda parte del mundo. Quisiera saber si eso permitió o está permitiendo incrementar la superficie que está cultivando o no. Y lo último, ¿qué tal de los lupinos? Bueno, so Hlynur, maybe you could take off your presentation.
Yep.
So we can see you.
Yeah.
And see us.
Yeah.
Please. Yes. Excellent. So first, the temperature that you present are mainly for the coast, no? Because inside it must be.
Yes, that's very true. It's for the lowlands, and well, it's the temperature I showed was for the Reykjavik area, which is the capital area. So of course, if you go up, and the central plateau is mostly 600 meters, it's a rather flat, and then we have mountains extending up to 2,100 meters. But the central plateau, it's different. And we do, up on the central plateau, we do actually have permafrost areas and such. Although, unfortunately, I say, we are slowly losing these because it's getting warmer, the permafrost areas.
And how many kilometers from the coast you have a quite warm climate?
It doesn't extend very far inland, because in most places, except maybe in South Iceland, the mountains start within 15, 20, 30 kilometers. You have the mountains, and then it quickly rises up to the central plateau. And farming or people, majority of Iceland live below 200, 250 meters. Hardly anyone above 300 meters. So,
like in Kirkjubæjarklaustur.
Yeah, Kirkjubæjarklaustur is actually the Mývatnssveit area, which you drove through actually many years ago with me. That there's the highest community of farmers, highest in elevation is 250 meters. But like I say, most farming and most people are living below 200 meters. It just becomes too difficult to live at higher ground.
Another question: who is belong the land that is not cultivated now? Is it belongs to the states, to somebody, to whom? Because this is for the next question.
The central plateau and most areas below 200 to below 300 meters belong to farmers or other landowners. But the central plateau and the mountains are property of the government or the state of Iceland, the people of Iceland. Yeah. So the central place is the commons. That's the common area. Yeah.
Because with the climate change, as it's warmer, I guess that you can cultivate more land than before.
You could live up there. Yes.
So what happened?
It could be.
How do you do?
I think people could then lease from the government, lease land. I don't think they will be able to purchase it.
Okay, and the last one is what's about the lupine?
Lupine. Yeah, the Alaska lupine.
Not of lupine.
Does everyone know that about that? Alaska lupine is a plant species that was brought to Iceland to combat the soil erosion. And it actually worked very well in stopping erosion in some areas, particularly in areas where there were not all the soil had blown away, and in lower areas and moist areas. The lupine worked very well, but, and there's always a but, isn't there? It proved to be rather invasive. It will choke other vegetation, so now it has taken over extensive areas of heathlands and grasslands and become a single species areas. So yes, it works well for stopping erosion, but there are other problems with it. And so what the approach today by the government is that we stopped using it to control erosion, but we're not doing anything about it except in nature conservation areas and also in areas above 400 meters. So lupine is not supposed to be used or planted in areas high up or in any kind of conservation, national parks and so on. But it's a problem.
So now we have plenty of questions that you can see on your chat on the side. The questions are done in English.
Okay, so, how do I access these? I don't see them.
You go to the screen down.
Maybe it's better that we can open the question to the people I think in the order was Dr. Shubhatra Panda. Sorry if I don't say correctly. After that is Dr. Alejandra Zúñiga, Mr. Rainer Horn, Professor Francisco Matus, and Jorge Ivelich. In that order, you can say your questions, and after we can give the word again.
So the first question, I don't know if you see
Dr.
it.
Panda?
Yeah. Tú abres el micrófono. Mejor.
Yeah. You can put on
Download
your
to speak.
speaker.
Hello. I have
Yes.
given my question in the chat box. Just now I am telling this. One is how continuous freezing and thawing affect plant nutrient availabilities in soil. And also another one, what is the cause of soil acidity in histosol? And question number 3 I have put in the chat box. It is how does drainage of wetlands affect ecosystem and soil fertility? These 3 questions I have put.
Okay. Yeah, can I see this written, because the sound is not very good.
If you go to the chat button down.
Ah, chats. Okay.
If you click on that, then you'll see the questions.
Okay. Okay. How continuous freezing and thawing affects plant nutrient availability in soil? That was the first question, right?
Yeah.
We have not done any studies on that. I do not know of any studies on that. But on the other hand, what happens is in these eroded areas, they do not re-vegetate on their own, because when plants get established during the summertime, and I will walk through the area and it looks marvelous. Oh, here's a plant, and here's a new plant, and there's a new plant. But then I come the next spring and they will all be on top of the soil, wilted, because the frost heave has tore them out of the ground. So it's only when we come in with some management, put on manure or hay or something to stabilize the surface, that plants can establish and revegetate the areas. But in terms of the nutrients, I'm sorry, I cannot say anything about that. I do not have any data on that. Question 2, what causes the soil acidity in histosols? Well, like I say, I'm not a soil scientist, but as plants over time grow there and humic acids form over time, it gets more and more acidic. Commonly in peatlands or wetlands, to bear us in, like in Ireland, abroad, you will have very low pH, but in Iceland, because of the basalt and because of the deposition, the pH is rather high for peatlands or histosols. It's commonly 4 or 5 up to 6, so it's quite high. Yes, then the third question, how does drainage affect ecosystem and soil fertility? Many of our peatlands are actually on slope. It seems strange to have a wetland on a slope, wouldn't the water just drain out? Well, it is, much of the Icelandic environment is sloping because it's a very mountainous environment. And water, because of differently densely layers in the mountains, water is seeping out of the mountains. You will have rows of spring, and then a peatland will form below. So it maintains a steady flow of water seeping out of bedrock through, always bringing minerals, and through the peatlands, and then seeping out of the peatland into the river below. That's the normal situation. When you drain these type of wetlands, you put a ditch above where the water is entering, above the peatland and the hillside, you're stopping the water coming out of the ground and from seeping through the peat, through the soil matrix and bringing in minerals. Instead, you put the ditch all the way around, and now you only receive rainwater. And rainwater is very poor in nutrients. It falls on top, seeps through the matrix and into the ditches, always taking some of the nutrients with it. It's like sort of like pouring the water over the same coffee again and again. You're washing out, always washing out some of the nutrients. So over time, we've seen many of the drained areas decline in fertility. What farmers do, if they are using it, they of course use synthetic fertilizers to maintain the fertility.
But do you have a lot of salt in the rainwater, sodium?
Yes, we do. There is tremendous sea spray in Iceland. All areas of Iceland do receive some sea spray, some salt, some sodium and chloride. But the seashore, the environment around the seashore receives tremendous quantities.
And how far does it affect the pH then?
I'm not sure of that. I would have to look that up. I'm not sure how.
It keeps the pH higher.
Yes.
Keeps the pH more stable.
It certainly should keep the height, but I haven't seen data that have attempted to estimate that.
Okay, sorry.
So should I move on to next question?
Yes, to Alejandra. Alejandra Zúñiga.
I'm here. Oh, thank you very much for the presentation. I enjoyed it very much. And I wonder if the climate change could alter the vegetation that can colonize this kind of environments. Specifically, I'm thinking in the wetlands, because we have some experience. I'm a plant physiology, and I'm thinking that some plants can alter the fluxes of water that can be evaporated from this kind of landscapes. I don't know if they are by climate change and increase of the temperatures, maybe could be affect these kind of things in your landscapes in Iceland that looks more like an Antarctica or Magellan land in Chile, you know?
Yes. Could you just say the very first part of I missed that.
Yeah, I wonder if by climate change and the increase of the temperature could alter the kind of vegetation that can colonize and alter the hydric cycle by evaporation, for example.
Yes. I think so. We're actually seeing, because we've had for the last 20 years, in the later half of last century, we did not have much increase in temperature, but for the last 20 years, we've had tremendous increase in temperatures in Iceland, and we're seeing much response by the vegetation. And for example, in some of the peatland areas, for example, around where I live, the water table is always lower now, and I think it is, and we're still receiving the same amount of rain, but I believe in part it is evaporation and evapotranspiration by plants and causing that. We've also had increased summers with droughts. What I should say, because of higher temperatures, we've had similar long periods of non-rain as before, but because of higher temperatures, the plants are now hurting, and because of evaporation and evapotranspiration, and all of a sudden the farmers who have the drained peatlands are using those have to water them, which they never used to have in the old days, and that's why they want to also re-wet them again. So I think, yes, it is problematic with higher temperatures, also in terms of the soil erosion areas, because one thing that happens in the soil erosion areas, these desert areas, is the reason why they're deserts also, and that's why Ólafur Arnalds, our soil scientist, he wants to refine the definition of a desert, because most definitions of deserts are associated with precipitation.
Mhm.
But he says it's forgotten in the definition of deserts if the soils or the ground lacks water holding capacity. So we have many areas in Iceland where they do receive enough rain, but the water, there's nothing to hold the water, and it goes all very rapidly down. And in many of these areas, it's difficult to revegetate them because plants will not have enough access to water. So even if it gets warmer, it will be even more difficult for vegetation to establish on these areas because of lack of water and higher transpiration rates.
Mm.
Should I see all this, I'm looking at the chat box, there are more questions here. Should I, or how do you want to do this? Or?
Thank you.
Yeah, okay.
So another one of
Jorge
Ivelic. Jorge Ivelic, después de Hlynur.
Jorge. Okay, first of all, many thanks for the presentation. This was excellent. Well, I have in principle two questions. The first is indeed, what are the annual loss rates of organic material due to that drainage, also including the climate change aspects? Do you have long-term data sets on this? And second, if we include the glaciation before, and the glacier is melted away, and so we should have a lot of horizontal platey structures, which would then even mean that the water will never infiltrate in the soil again completely, but it's only in the top part where the water remains and goes then laterally. So in principle, two questions. First is, what are the annual loss rates? And second, how far do you still see the glacial origin in the soils today concerning your water holding capacity or the water loss because of lateral flow?
Yes, the losses have been estimated. There's about between 4 and 6 tons of carbon per hectare per year. Okay. And we have approximately 4,000 square kilometers of drained peatlands. So you see that's it's a tremendous amount. It's the #1 emission factor in Iceland. It's the drained peatlands in terms of because the society is so small. We are only 340,000 people. So even if you drive our cars and so on, but we've drained so much of the peatlands that it's emitting, even though each square meter doesn't emit much, but if you add it all together, it's a considerable amount.
Does it increase over the last years?
Just with well, it is greatest in the beginning, but then it enters sort of a status vary for a long time. As long as there is organic matter there, as long as it's aerated and the drainage is maintained, then it will emit carbon for a long time. But in some areas, the drainage is being reduced because ditches fill in and so on, and the subsidence of the surface, its compaction and so on, because of its being broken down, then the drainage reduces and then the emission is reduced. But if it's maintained in fully drained state, it can emit for a long time. We are estimating the surfaces that we're losing 0.5 centimeter a year, and most of these are 2 to 4 meters thick. So you see that's 5 centimeters a decade and 0.5 meter a century. So if it's 4 meters, it can last a long time.
Yeah. Is there any hydrophobicity due to this decay?
Yes, there is in some areas, particularly with the Histic Antisones, that one can become quite hydrophobic. So, and farmers can have hard time working that kind of material if it's in the surface layers. It can often form these hard, rock, not rock, but pieces of soil that are quite hydrophobic and difficult to vegetate and so on. Yeah.
Okay.
How
okay, continue.
No,
it's okay.
Questions.
Okay, I'm stopping. Many thanks again. It was perfect.
Jorge Ivelich.
Hi.
Por ahí.
Hi, thank you. Hi, everyone. Thank you for the presentation. It's quite interesting. I have a simple question for you. Over which material, are these histosols are other maybe glacier or like big tephra, volcanic tephra, or it's a mix? This deposit, and which is the size? If it's glacier, which is the average size of the particles? It's like big boulders or very sandy lime.
You're talking about the vitrisols rather, not the histosols?
No, the histosols, it's like because in Magallanes we have the same landscape or very similar. But there are these big histosols here are other are deposit over glacier material.
I see. You're talking about the underlying. Okay.
Yeah. These peatlands,
It is two types in Iceland. It's on formerly glaciated areas with where the glacier has left a lot of fine material, very compacted. That's very common, but even maybe more common is on former seabeds, because Iceland is very, very thin. Iceland is just a crust. Iceland is only a few kilometers thick. So when during glaciation, when we had several kilometers of ice, the ice pushed Iceland down, and this seashore was 80 meters up. So when the glaciers melted, the land lifted out of the ocean, and large areas that were used to be seabed and hence had fine silt, like in estuaries and so on. That's where lots of the peatlands formed, because those were densely, it was like cement on top of the underlying basalt layers, filling in the crevices and so on, making a very dense bottom or surface, non-permeable of water, and hence
okay.
Okay,
thank you.
Bueno, now it's turn to Andreas Datwiller. Andreas, por favor.
Okay, my questions is what are the types of colloids and in the chat that are most found in Ireland? What is the colloid most found?
What are the most common type of what? I didn't hear.
Colloids.
Colloids, yeah. Oh, now you're asking the wrong man. I'm not very good with colloids. We have, I'm not exactly sure how. Like I say, I'm not a soil scientist, so I'm not very. I'm not really the best one to answer that question. I'm sorry, but you mean, are you referring to colloids in the soil or in like water seeping out of the soil into the water, or? soil colloidal.
Soil colloid.
Yeah,
Soil colloid.
yeah. I'm sorry. I don't want to say something silly, so, because I'm not really that well versed in that. Sorry to have to decline to answer that question.
Okay, no problem.
I could read up on that in the Soils of Iceland and send you the information. That's the best I can offer.
No problem.
Thank you. Okay. Now, Francisco, Pancho, Matus.
Hola a todos. Thank you very much for your nice presentation. Do you have some indication of potholes there in Iceland?
Not really, no. It was actually prior to the Anthol category surfacing within the soil taxonomy or soil systems. Then there were some early soil scientists who came and visited Iceland, explained some of the soils that they were actually potholes. They believed so, but we've then found out that since that these are not really present in Iceland. No.
Okay, thank you.
Ahora está Valentina Cárdenas. Valentina Cárdenas. Bueno, hizo la pregunta en español. No sé si puede hacerla en inglés. Si no, lo hago en su lugar. No. Sí, entonces la versión en inglés. Due to the low temperature and considering the factors and process of soil formation, dirías, you will say that cryogenic processes have a main role for the soil formation than the process of chemical processes.
Let me interrupt you there. I need to go quickly to the bathroom. I'm very sorry. Okay. Everyone just get a cup of coffee.
Bueno, por esta vez hicimos la presentación en inglés y conversamos en inglés. Normalmente, y es uno de los objetivos de la red también, es que sea en español para latino o para castellanos hablando. Pero de vez en cuando habrá excepciones, como en este caso. Bueno, esperamos un poquito. Después, ¿nadie más quiere hacer preguntas después de Valentina? Tenemos todavía un poquito de tiempo. Bueno, 20 minutos. Laura va a hablarnos un poquito, supongo.
No, para nada.
¿No?
Respecto a los coloides, yo nada más puse en el chat que el doctor habló de la gran cantidad de alófanos en algunos suelos de Islandia. Es todo, solo un comentario.
Bueno.
Los alófanos están considerados químicamente como partículas coloidales.
Sí, sí. Es cierto. Bueno. ¿Qué puedo decir? Bueno, yo fui varias veces a Islandia y sí, hay muchas similitudes con Chile.
Okay, I'm back. Sorry about that.
Yeah.
Thank you for staying. Could you repeat that question by Valentina?
Yes. Due to the low temperature and about the process of formation, soil formation, what is your point of view about the process due to the cryogenic processes, which are most important, cryogenic processes or chemical meteorization processes? Is there one dominating the other one, or
Yes.
they are similar on the same situation?
I wouldn't know which one to bet on, really. Especially, again, I'm not a soil scientist, and I'm not really studied into this. I'm sorry, I wouldn't be sure which one to say was played a great role, unfortunately. But the cryo environment is certainly important, but yeah.
And due to the climate change, do you observe could you observe some change of or processes in the soil?
I think we could, but we have not done any studies particularly on that, except for one project which I'm not involved in, but my colleague. It's called FORHOT, FORHOT, like hot forest, FORHOT. It has a web page and everything. It's very interesting, and they're studying both heating of in a grassland and in a forested area. And okay, heating of soil has been done in many places, but this is natural heating. We had the earthquake in 2008, a very strong earthquake in South Iceland. And following that earthquake, the ground started to warm up in a large area near the town of Hveragerði. And it started to warm up all the way up to 60 degrees, and killing trees and everything. And quite dramatic, seeing trees toppled off and everything. And so what the scientists are doing there, they have established gradients from no warming to up to 40-50 degrees above ambient. So every 2 to 5 degrees, they are looking at soil processes and how it is changing everything in terms of both the chemistry, the carbon, and various properties. And it certainly does speed things up a lot. I do not have these data available right here at the present, but there are many scientists involved in this. Several universities in Europe, in Belgium, in Sweden, I think the Netherlands and Switzerland, along with our university, are carrying out research there. I think there are 5 PhD students working on there now, and there's already 2 PhD students have finished their thesis. So there's lots of studies being done in that area, which is it's a very nice setup because it's a natural heating from the ground up. Of course, then it's the soil that is warming, not really the climate on top. But it's still, I think it probably is very important in trying to understand what happens to soil as it warms up. But I'm sorry, I do not have that data right here with me.
Okay, thank you. And the the trees are growing up now? You can say how many hectares of forest you have in Iceland.
Yeah, well, that particular area is just a coniferous forest which was planted there. And then this earthquake happened and a new geothermal area started, and the ground started to warm up, and there was one house in this area, and my friend was living there, and he couldn't live inside the house anymore because it was 45 degrees inside the house. It was basically the ground around the house was warming up. But in general, you ask about the forest in Iceland, less than 2% of Iceland is forested. It used to be a lot more birch woodlands, but these quickly got reduced when humans came, cut these down and for fuel and so on. But there are quite substantial forestation projects going, although we argue, of course, back and forth whether we should be planting exotic trees or native trees and so on, like everywhere. And also there's debates about how we should be planting. In some places they are plowing up very rich and beautiful heathlands, berrylands, and putting trees, and lots of people don't like that. In my view, forestry should be aimed at these areas which are semi-eroded, which have lots of erosion spots, because once you get the trees starting to grow up, these erosion spots usually close up on their own. They will recover on their own. So I think we should aim at areas, problematic areas, instead of taking fully vegetated areas that are have a different ecosystem presently. But this can be argued.
You have a question? Thank you. You have a question of Hlynur.
The discussion about the upheaval rate of the because of the glacier melting.
Mm-hmm.
How far do you have data on that? What is the annual or the decades-wise upheaval rate, and how far can you still see the former ice glacier-induced stresses in the soil? Do you see some platy structure below after the glacier has melted away?
Yes, we see evidence of past glaciers, yeah, in many places, and the rates are highly variable depending on which part of Iceland. Where I live here, we're actually close to zero, but the further out to east and west, there's increased rate, and it's a few millimeters a year, I believe, in some places, if I remember correctly, 1 or 2 millimeters certainly. And for example, I don't know if you've been to Reykjavik, but at the tip of Reykjavik, there's called the Seltjarnarnes, that means the Seal Pond Peninsula, and that is now part of the has been raised up and is no longer there. So the name indicates a different situation.
Okay.
And it's interesting, like there was recently a gravel pit in Western Iceland where they were mining gravel for road construction, and they came up on whale bones at 80 meters, way up in the, up the mountain slope, 80 meters above sea level, and quite recent. I mean, this is not like,
okay.
We're not talking about hundreds or thousands of years ago. This is only in the last 7,000 or 8,000 years that it's risen this much.
Okay. Okay, thanks so much.
Yep.
So thank you. There is no more questions, and we are nearly finishing the presentation. Well, no hay más preguntas, ¿verdad? Así que vamos a terminar la sesión. Thanks a lot, Hlynur.
No, thank you.
Many thanks. That was perfect.
Yes, well, thank you all for attending, but I'm sorry I couldn't answer all the questions.
Oh, it's perfect.
No problem.
Dame la palabra.
Para anunciar. Bueno.
Okay.
Vaya, Ingrid.
Okay. Thank you, Hlynur, for your talk. Hlynur is part of our team on volcanic soils, so it's our pleasure to share this talk. You can see this talk on our website, redsoilvolcanicos.com. So now I'm going to talk about our next talk in September 3rd. It will be in Spanish, Biochemistry in Anthols by Dr. Juan Carlos Loaiza from National University of Colombia. I'm going to share it.
Puedes decirlo en español también.
Yeah. No, estaba agradeciendo a Hlynur por su presentación. Hlynur es parte de nuestro proyecto Suelos Volcánicos. Nuestra siguiente presentación va a ser el 3 de septiembre. El título es Biogeoquímica en Andisoles por el doctor Juan Carlos Loaiza de la Universidad Nacional de Colombia. Así que lo esperamos a las 11:30 de la mañana, el jueves 3 de septiembre.
También para decirle que todos estos seminarios se van a terminar en enero, pero que vamos a seguir después, así que si alguien de ustedes tenga algo que presentar, pues nos avisan y nos vamos a organizar para preparar la segunda sesión.
Así que también pueden revisar la presentación de hoy en nuestra página, que es www.suelosvolcanicos.com. Ok, eso es por todo por mi parte.
Bueno, José, ¿algo que decir?
Not too much, because I do not have the possibility to assist to the Hlynur presentation. Actually, I was in 2 sessions of Zoom at the same time, but I take a look on all the slides, and I will have the opportunity to see later the saved version in our website. But many thanks, Hlynur. It was really a pity to have at the same time 2 activities, but
Yeah, that's okay.
it was
Good to see you.
nice to see you again. Many greetings to your wife. Many greetings to
Yeah.
Mr. Horn as well. I see that you are at home.
Yes,
Yeah.
I'm at home and I have to recover, but I'm fully recovering. Slowly but surely.
That's good.
Ja, das passt schon. Geht besser. Und euch geht's auch gut.
Uns geht's
Toll.
ziemlich gut. Ja, es ist im Moment nicht so warm wie in Deutschland, wie ich mal gesehen habe. Aber
28. Ja.
das läuft
Ja, super.
eigentlich besser. Okay.
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 So, muchas gracias.
Bueno, gracias a todos.
Gracias. See you then. See you, Hlynur.
Thanks, Hlynur.
Bye.
Yes.
Bye bye.
Bye bye.
Muchas gracias.
Gracias.
Ciao.
Ciao.
Nice surprise, Dr. Hlynur.
Yeah. Nice to see you as well, Laura. See you next time again, and I hope we will be very